We made it. We're here down lower. We came from the Alpine and we're now down at McGee Creek, which is in the North Fork. This water will eventually get into the North Fork of the Flathead River. And these researchers are looking at cutthroat trout and trying to determine how stream flow and stream temperature are affecting these fish. Let's go find out more from Clint and his team.
So we're here at McGee Creek, which is a tributary to the Flathead River. And this is one of our long-term study areas where we're trying to understand how climate change is impacting cold water species that live in these streams and rivers and lakes throughout the northern Rocky Mountains. And in this stream, it's home to the native Westslope Cutthroat Trout. That's Montana's native fish that survived cataclysmic occurrences throughout geologic time. They've survived droughts, wildfire, flooding, glaciation, you name it. These species are adapted to persist in an ever-changing environment. But most recently, these systems are warming at an alarming rate. We recently analyzed 100 years of air temperature data throughout the northern Rocky Mountains and found that this area is warming at 2 times the rate of the global average. That in turn is decreasing the snowpack in the high country, which is eventually affecting the stream flow and the temperatures that these cold water dependent species depend on to survive and persist under a changing climate. We're also seeing an increase in the frequency and magnitude of extreme events like droughts, wildfire, and flooding. Most notably on the shoulder months of the winter, we're seeing the snow turn to rain because of these warming trends, and that in turn is increasing flooding events during the winter period. We're also seeing as these base summer flows get reduced during the summer months, things dry up and we're seeing wildfire events, and these long pronounced periods of drought are having potentially devastating effects on these trout populations. Here's a graph showing data for the temperature of our rivers and streams throughout the northern Rockies. And as you can see, as spring runoff occurs, temperatures increase. They're at their warmest extremes during the summer period and then decline in the fall and winter. We can then use these data to model or forecast future temperature scenarios. And as you can see here, under a warmer future, we can expect temperatures in the rivers and streams to warm considerably during the summer months and during the shoulder months of the summer. We're also monitoring the stream flow regimes throughout the northern Rockies, including Glacier National Park. And here's a graph of the stream flow regime. And as you can see, it is low during the winter months. It increases during the spring runoff, and flows decrease during late spring and reach base flow conditions during the summer months. We can then use this information to then model or forecast future flow regimes under climate change. And as you can see here, we're already seeing a 2 to 3 week earlier spring runoff. That's leading to less pronounced peak spring flows and declining flows during the summer months. And what does that mean for fish? Well, it means less water in the creeks and rivers during the critical low flow period during the summer, as well as warmer temperatures.
Whoa, Clint, that was a lot of information and sounds like a really big project. So what do you do? What kind of data can you get here at this creek and other ones in order to tell how this system might be changing?
So we have to start at a very local scale, at a stream scale, to understand how the entire ecosystem is being affected by climate change. So in this particular study, we're trying to determine how these fish are surviving, how they're growing, and how they're persisting over time under changing stream flow and temperature regimes. Fish are great indicators of aquatic ecosystem health. They rely on the surrounding water to regulate their body temperature. They move and migrate throughout these interconnected river and lake systems up to 250 kilometers. So they're great indicators of the entire watershed's health. And so these streams like McGee Creek are where they go to spawn and reproduce.
Okay, so you're saying that these little fish we're getting right now, they don't just stay here. They're gonna move somewhere else. And where did they go?
So the adults migrate up to 200 kilometers from Flathead Lake all the way up here.
Whoa.
Using their olfactory cues, meaning they
all
smell.
the way from Flathead Lake?
Yeah, they literally smell the water and smell their way back to their home stream where they were born.
And that's where they then reproduce and have new fish.
Exactly.
Okay.
And so we are sampling the progeny of the adults that have spawned here the last 2 to 3 years.
Okay.
These juveniles will rear here for 1 to 4 years, and then they will leave the stream out to the large river or the lake where they grow to maturity.
Will you actually be able to monitor the ones that end up coming back?
Yeah, we will. So what we're relying on is this really cool technology where we can implant these tiny transmitters into the body cavity of fish.
Wow.
And we can track their individual movements and how they're growing and how they're surviving.
Year after year.
Year after year. So this has been a long-term study where we have recapture histories of individual fish that we started 8 years ago.
And so knowing the histories of these particular fish will give you a picture of the kind of the whole population of cutthroat trout overall.
Exactly. So we can monitor under a low water year or a high water year whether fish are growing and surviving better or for worse. And then over time, we can build models where we can understand at the population scale how these populations are responding to this climatic variation.
Okay, so there's just kind of a lot of different elements. You have to start off in the water, but eventually it looks like you're going to get to the computer modeling stage where you can then picture on the landscape what this data and other data points are telling you.
Exactly.
Okay.
So we're starting at the individual fish level, to the stream population scale, to the interconnected metapopulation scale to truly understand.
Metapopulation.
Yeah, and that's a network of connected populations that overall is really critical for the persistence of the cutthroat trout in the Flathead River system. So we need to look at the entire system to understand how climate change is affecting.
And even the work you mentioned before where we went to the Alpine, right? We went to the Alpine and down here, just knowing how all the changes across the landscape are affecting all the species in the water.
It's all connected.
Yes. Okay.
And so we're trying to understand how the changes in the high country are manifesting themselves downstream throughout the river networks. Widespread impairment of trout reflects numerous human activities that have gone on for the last century or two. Those include habitat loss in invasive species that predate, compete, and hybridize with our native trout populations.
Wow, thanks, Clint, so much for sharing all of this information with me today. I really can see that understanding how these rivers, both up in the Alpine and down here, how they're changing, how the species are reacting to those changes, is really good information for scientists to know, but also for park managers who are going to have to manage for these species in the future. And I'll be honest, Clint, sometimes with talking today, it's been a little overwhelming for me. I felt kind of sad or like I was losing things or just the loss of maybe some of these amazing species. And so one point you said there's a lot to be hopeful for, and I guess maybe I just need you to tell me what that is today. Can you tell me why
Absolutely.
I can be hopeful?
There is hope. We're right here situated in the crown of the continent ecosystem. It's one of the most biodiverse and intact aquatic ecosystems in North America. Glacier National Park is right in the heart of it.
Yeah.
And we still have these cold, clean, complex, and connected habitats that these fish need to survive and adapt in. We still have these populations that have survived for millennia under extreme climatic changes. So we still have all these pieces that are still here that are going to be really critical for resiliency and adaptation in the face of climate change.
Cool, and what we do today really will affect what fish we have tomorrow. Isn't that what you've been telling us today?
And absolutely, and managers are getting after it to restore, conserve, and protect these habitats and these populations across these riverscapes. Managers are dealing with habitat issues, improving stream connectivity, setting aside areas for native fish reserves, even creating new areas of climate refugia for the future.
Places where the fish would be able to live.
Absolutely, and dealing with legacy effects of invasive species like widespread stocking of rainbow trout, where managers are proactively trying to suppress them and restore the cutthroat trout. So there's so many good things going on within this landscape that there's absolute hope.
And it takes a lot of people. I know there's a lot of researchers and managers, but there's also a lot of community members and nonprofit organizations, just a lot of different people working on this.
Absolutely.
And so it kind of takes like a whole bunch of people to make this happen, but I have seen it on the ground. So you're right, now I do feel a little more hopeful because yeah, that is happening every day. So really exciting to talk to you, Clint, today and to learn all about the amazing research you're working on. I can't wait to find out more and find out what your data tells you over the years. Thanks everyone for joining us today. I hope that you enjoyed our two-part series on our riverscapes here in Glacier National Park and how they're changing with a warming climate. So thanks again, Clint. Thanks everyone for joining us. Happy Glacier Science Day! Bye!
Thank you.